Okay, so I want to review a couple things that you need to know for um, moving straight ahead investigation 3.4. Um, so you are going to need your graphing calculator. I'm going to go over a couple things on that. And you also need your big idea notebook. Okay, we're going to write some things down in that. Okay, so make sure you have both of those materials. Okay, first thing I want to go over is we started this investigation by looking at linear equations, like let's say we have y equals 3x plus 2. And we tried to figure out if, let's say, x was equal to 30, is there a way we could figure out what y is? Okay, so first we tried to do that graphically with our graphing calculator. So if you remember with your calculator, it might be a good idea to just kind of clear and clean it out a little bit in case you've got some things left in there from earlier. So you can always reset your calculator by pushing the second button and then the plus sign. Okay, go to reset. That's down to number 7. Reset all the RAM and then go ahead and say 2 and reset. Okay, so it should now have my RAM cleared. Okay, so then what we used our graphing calculator for to solve this problem is we went ahead to the y equals, and we typed in the equation y equals 3x. I'm going to put a 3 here, x plus 2. Okay, and then there's a couple ways that we can figure out what y is when x is 30 by using a graph. All right, so you could first push the button that says graph. Okay, and it makes that. And we found out that we could trace along the graph until we found out that x was 30. Okay, so it does look like this side have to go pretty far on the graph. So we also found out that if we push zoom and then zoom out and then enter, we could also maybe spread the graph out a little bit so we could see more. So I'm going to go ahead and trace here, and I want to figure out when x is 30, what y is. Okay, and I still haven't gotten there yet, so I'm just gonna kind of hold my trace button. Oops, it looks like I went a little too far. So, and then if we kind of arrow back and forth, we're trying to get this x to be 30. We found that if we actually just type the 30 in and push enter, it would actually tell us that when x is 30, y would be 92. Okay, we also found out that we could have figured out when x is 30 what y is by going to the table. So push second and then table, and then I could slide down and figure out, let's see, I want x to be 30. So I'm going to go ahead and head down there, and I see that it's equal to 92. Okay, so I'm going to give you one to try. So let's go ahead and just reset your calculator. So second memory 7 1 2. Okay, get it kind of cleaned out again. Okay, how about if you have the equation y is equal to negative 5x plus 2, and you wanted to find y if x were 3. Okay, so, and a little hint, the negative sign's down here. So go to your y equals, type your equation in. First, see if you can find it in the graph by tracing, and then go ahead and find it in the table and see what you get. Okay, how'd it go? Negative 5x plus 2. I'm going to go to graph. I'm going to trace, and I want x to be 3. Okay, I'm looking for x to be 3. Looks like I get kind of close. Oh, okay, and then I could actually type a 3 and it would jump there. Looks like y would have to be negative 13. Let me check on the table. When x is 3, y is negative 13. Okay, so the graph and the table show all of the pairs of numbers that x could be if you multiply it by negative 5, added 2, and got y. Okay, but what we're looking for specifically, how about if we knew that x was 3, what would y have to be? Okay. All right, so then we also solved some of these. So go ahead and let's go back to that other equation. y is equal to 3x plus 2. So you can type that one back in there. So y equals 3x plus 2. Okay, now how about if x were equal to, if y were equal to 50, what would x have to be? Okay, so let's see if we can solve that one. So I've got y is equal to 3x plus 2. I'm going to go to the graph, and I'm going to trace, and I want y to be 50. Okay, again, I'm going to have to go pretty far, so I might want to zoom out. I'm going to start tracing again. So I want y to be 50. Okay, it doesn't look like I'm getting exactly there. So it looks like it's between, it's not 15, but not 16. Let me just try typing in 15. Well, that didn't work. How about 16? Okay, so it looks like x would have to be 16 for y to be 50. Okay, I could also go to the table. Okay, and I'm scrolling down and I want to know what x has to be when y is 50. Okay, and here I'm getting 50, okay? All right, I'm going to give you one to try. Okay, why don't you go ahead and clear out your calculator. Okay, and let's go ahead and type in y is equal to 6x minus 3, okay? And I want you to figure out what x is when y is equal to, let's see, about 27. Okay, so see how you do on that one. So what's x? Okay, how'd it go? Did you type in 3x? Oops. 6x. 6x minus 3. Okay, did you go to the graph? And I'm tracing until I find y is equal to 27. Okay, so it looks like it's between 4 and 5. I'm going to just go ahead and try 5 and jump there. It looks like it is. Okay, if I go to the table, I want y to be 27. I can also see that x would have to be 5 from there. Okay. All right, so that's how you could have used technology to do this. How about if we wanted to work with symbols? Okay, so now I want you to take out your big idea notebook and we're going to write down a few notes. Okay, so let's title this Moving Straight Ahead, Investigation 3. All right, so my first big idea is, how do you solve a linear equation using symbols? Okay, so instead of using a graph or a table, could we have done some of those problems algebraically just by manipulating the symbols? Okay, so here's the first one. So if you know x, find y by replacing x with the number and then following the order of operations. Okay, so our earlier example, let's say y was equal to 3x plus 2, and we wanted to know y when x equals 30. It's a little tedious to spend all that time putting that into our graphing calculator and scrolling up and down or looking at the table. I wonder if we could have just done this paper and pencil. All right, so I'm going to go ahead and put 30 in for x. Okay, and then these to number next to a variable implies multiplication, plus 2, and then I'm going to follow order of operations. So what's 3 times 30? That's 90. I'm going to add 90 plus 2. Y is equal to 92. Okay, so that works out just like how we had figured that out earlier on our calculator. In that particular equation, if x were 30, y would have to be 90 for that to be true. Okay, so how about if you know y, find x by replacing y with the number, and then get x alone by using the balancing method. Okay, so in that balancing method is what we've been trying to do like all week. Okay, so let's say I've got that y is equal to 3x plus 2 again, and I know y has got to be 50. Okay, so I'm going to go ahead and replace y with 50, and then I've got 3x plus 2. All right, so this wasn't as easy as the other one where I just had the y alone already and I just had to like multiply and then add. So in this one, I really want to kind of undo what's being done to x by picking things to add or subtract or multiply and divide both sides by, okay? And then we start doing some of these with models, like this could be like 50 coins is equal to 3 pouches plus 2 coins. But ultimately, as long as I did the same thing to both sides and picked something useful, I could solve this. So I'm gonna start by subtracting 2 from both sides, okay? And then what's 50 minus 2? I'm gonna write that new answer, so 48. And then if I would have taken those 2 coins off of this side, I'm going to get 3x over here. And then I still want to know what x is. So to remove that multiplication, I'm going to do that opposite operation. I'm going to divide both sides by 3. Okay, and what's 48 divided by 3? That's equal to 16. Okay, so with this one, it was a little bit trickier because my variable was kind of mixed with these numbers. So I had to keep undoing until I got it alone. All right. So once we sort of figured out that whole method of solving equations by just working with the symbols, we started to extend that a little bit more, okay? So you should also be able to solve these symbolically, okay? So let's see, how would we solve something like this symbolically? So I'm gonna write you should also be able to solve these symbolically. Okay. So let's say that I had my first example, 100 plus 3x is equal to 5x plus 40. Okay, so with pictures, this was like 100 coins plus 3 pouches was equal to 5 pouches plus 40 coins. Now again, you can add or subtract whatever you want to both sides, as long as you do the same thing to both sides, but pick something useful. Like if I added 2x to this side and 2x to the other side, it's not going to get me closer to getting my x isolated, okay? So, something useful. Okay, I'm going to subtract 3x from both sides. Okay, so if I subtract 3x from both sides, what do I have left on the left side? My new equation is now still balanced. Now I have 100 is equal to 2x plus 40. Okay, so I'm getting closer to finding out what x is by balancing it out. What could I do now? How about adding 40? Whoops. That's not a good idea because then I'd have 80. How about subtracting 40 from both sides? Okay, so then I get 60 over here, 2x over here. All right, and so now what could I do to undo that 2 being multiplied by the x? So what's the opposite of multiplication? It's division. So now I'm going to divide both sides by 2. Okay, so I'm going to x is equal to 30. Okay, once you get the x isolated, you're good to go. All right, let's try a little harder one. How about if I had 8x minus 20 equaling negative 2x? Whoops, rats. Plus 50. Okay, so what could I do to both sides? Pick something useful. Okay, so opposite of subtracting 20, how about if I try to add 20 to both sides? Okay, what am I going to have left on the left side? 8x. I was able to make a 0 equal negative 2x plus 70. All right, now what useful thing could I do next? How about adding 2x to both sides? Okay, so now on this side I've got 10x equal to 70. And then my last thing I'm going to do is I'm going to divide both sides by 10. Okay, so then I get x is equal to 7. All right, so just pick something useful that you can do to both sides that's eventually going to get that x alone. Okay, that's it for your notes.